Today we'll be talking about the topic resistance. Now, to understand resistance, let me take a wire, okay, generally in a battery, and if we connect this wire to a battery, this way it will be, the electron flow will be indicated by the arrows. Now class, if we try to see what is going on inside this wire, inside this conductor, if we zoom it out or if we try to look inside this, how the electrons are behaving, let this kind of arrangement will be seen if you zoom it out. This kind of electrons will be there. I'm making few, but there will be trillions of electrons inside, and they are moving in a random direction like this in the beginning. But the moment the current will be flowing there, the cell is there will be potential difference, and it is a high potential, it is a low potential, so electron will flow from high potential to low potential. As these are few electrons, so they would be flowing. They can be shown in the diagram like this, okay. But now consider the reality. There will be trillions of electrons, so definitely there are chances they will be colliding with each other. Means these two electrons can collide, and what will happen after the collision? Their speed will be slow, okay. Again it will gain the energy and it will again move. Same will happen to the other electrons. They will collide and their energy will be lost, and again they will start to move. In this, due to these reasons, their rate of flow will be slow. And we know rate of flow of charges is called current. So current will become slow. So here, this thing, due to the collision of electrons, losing of energy and losing of the speed, gives a new term to us. This is called resistance. Okay. So resistance can be defined as, so here you can see, due to the collision of electrons with each other and other factors, in some other factor can also be there, electrons lose their speed and current gets reduced. This obstruction to the flow is called resistance. It is represented by R. Now from Ohm's law we know that B proportional to I. If we remove this I, this R is a constant and this is the resistance, okay, and it depends on so many factors, but it remains same for this particular wire, the material of the wire we are using to make it, okay. Now we can find out the values of the units of resistance as well as the definition of R by this formula. So here you see R equal to V upon I. So SI unit of voltage is volt and the current is ampere. So it is symbols for both V upon A. It can also be named like the ampere is the name of scientist. Similarly, to recognize the ohms contribution, we can put another unit for that is ohm, and it is represented by a Greek symbol called omega, right? Now the another question is, define 1 ohm. How will you define 1 ohm? That is very simple. By using this formula we can define 1 ohm. How? Here we look, we know R equal to V upon I. If we take this V, voltage equal to 1 volt and current equal to 1 ampere, it gives us 1 upon 1. So R equal to 1 ohm. Students, whenever we define definition in physics, we take the help of these formulas, we put right side values 1 and 1, and we bring our conclusion to this kind of values so that we can define them in a statement. We'll encode them all in our statement. How? We can say it like this. That for any conductor, if the potential difference of 1 volt is applied across its ends and the current flow is found to be 1 ampere, then resistance can be equal to 1 ampere. Resistance can be of 1 ohm. How to write this? This way we can write, for a conductor connected to a battery of 1 volt and the current is 1 ampere, then resistance of the wire is 1 ohm. Is that fine to you? Now we come to the another discussion, that whether the resistance is good or not. Actually, resistance is most of the time it is not good for us. Actually, what it's doing, see, we want to pass electricity from one place to other place, and now if you look into this diagram, we want to move these electrons as fast as possible from one place to other place. We increase battery for the same purpose. But what happens? Due to resistance, these electrons are losing their energy, the main cause of resistance. So here, resistance is not good for us. So in like most of the cases at our home also, many electricity wires are there. Outside the home also, high tension wires are there. All have this property because for making the flow of things for the current, we need electrons. So electrons are always found in metals very much. They are free electrons. And definitely we cannot minimize this collision of electrons with each other. Then what we do? If we have to remove this resistance, if we have to reduce the effect of resistance, we have to solve this problem. And for that, first of all, we should know what are the factors on which resistance depends. Once we know the factors, we can deal them one by one in order to reduce the resistance. So next topic will be how to reduce the resistance. This is the new topic, factors affecting the resistance of any wire. Again, let me see this cross section of the any conductor. Here students, you can see some electrons over there. What if I increase the area, means it is a smaller one, if I make it a bigger one, so I think the electrons will have more space to move apart from each other, and in this way the collision will be reduced. So means we will have a better flow of electrons if the area will be more. So it means the resistance is depending on the area inversely, means अगर आप एरिया को बढ़ाएंगे तो आपका रेजिस्टेंस अपने आप कम हो जाएगा, क्योंकि इलेक्ट्रॉन के बीच का गैप बढ़ेगा और उसकी वजह से इनका कोलिजन कम हो जाएगा. इसको हम ऐसे लिख सकते हैं, रेजिस्टेंस प्रोपोर्शनल टू 1/area, इनकी रेजिस्टेंस इज इनवर्सली प्रोपोर्शनल टू एरिया. अच्छा, दूसरा फैक्टर यहाँ पे पॉसिबल क्या है कि अगर ये वायर केवल इतना सा होगा तो इलेक्ट्रॉन को यहाँ से यहाँ तक जाने में कम टाइम में अपनी एनर्जी को लूज करना पड़ेगा. अब मान लीजिए यही वायर अगर यहाँ तक होता, इसका लेंथ ज्यादा होता, तो कोलिजन हर बार में बढ़ते रहते, तो इनकी जितना लंबा वायर होगा उतने ही टाइम में कोलिजन होंगे और उतने ही इसका एनर्जी का लॉस होगा. इसका मतलब हुआ कि दैट इफ द लेंथ ऑफ वायर इज इंक्रीज, द रेजिस्टेंस विल कीप ऑन इंक्रीजिंग आल्सो. तो हियर इज द सेकंड कंडीशन, it depends on the length of the conductor. Let we assume length of conductor is L. Now if we combine equation 1 and 2, what we get? This way we will get R proportional to L upon A. Now see again, it's a constant, so we can remove this constant by any proportionality constant here. This is a proportionality sign, so we can remove it. So this is R equal to rho L upon A. This is a Greek symbol called rho, similar to the P, but how to write it, most of the students face the problem. So let us say, if you have to write a P, so you write P like this. So we are not writing P here, so better you write like this. So it's a rho. Again I'm writing here, you make rho like this. So this is a Greek symbol, rho, R-H-O. Okay, this is another quantity. This quantity is actually depends on the nature of the conductor. You know, nature of the conductor means it depends on the wire is of copper, it is of iron, and it is of any other material. Length or area is another thing. This depend on us, but this depends on the nature of the material of the wire. It may be copper, conductor, iron, silver, etc. So that thing also depend now, right? So this constant is called resistivity of the conductor. Now in physics we know that whenever we encounter a new thing or we encounter a new particular constant, we always try to define it. In class 9th you might have seen a constant called gravitational constant, okay, like this, F proportional to m1 m2 upon r square. So F equal to g m1 m2 upon r square. You might have seen this kind of things in your class 9. So we try to define g also there. So similarly, new constant we encounter today, so we will try to define it. Same way the way I told you previously for r, we will define it now. How to define? Let I explain you this. Simple methods are there. Just you have to remember this formula and you can define it very easily. Okay, let's see. For definition of this, first of all we'll write the formula R is equal to rho L upon A. If L is equal to 1 meter and area is equal to 1 meter square, so I think we are left with R is equal to rho. But students, R and rho both are not the same thing. It is a resistance and it is a resistivity, but here they are equal. So whenever this kind of things arises, we call them numerically equal, means it can be 2, it can be 2. That is the only thing. Remaining of the time they are not same things, but numerically they are same. Just like 2 rupees and 2 human beings, number is same, but rupee and human being cannot be same. Same condition is here. Now whenever we will define resistivity, we will try to synchronize, we need to include these all things in a statement. How to write? Let I write the statement, then I'll tell you how to do it. Here we see resistivity is numerically equal to that resistance. See, numerically equal to that resistance which is caused due to a conductor of unit area and unit length. Unit means 1, so 1 length and unit area. This is how you can write the statement of it. Okay, now another thing we come to, what is the unit of resistivity, because it's new, we have defined, definition is done. Now we'll write the unit of. So here first of all we'll have the basic formula R equal to rho L upon A, because you have to find out it's a unit, so we'll make it subject first. See, rho equal to R A upon L. So here A is the area, we have taken this by the cross multiplication, and L is in the denominator. Now it's very easy, you write the units of all these three quantities, you can find the unit of rho also. So we get the unit here, ohm, it's a meter square, it's a meter, so finally the ohm meter. The ohm meter is the SI unit of the resistivity. Okay, so it was it about the topic resistance and resistivity based on class 10th. You can leave your doubts and your feedback on the comment section. Thank you.